We're solving the Intext questions 12.11 using curved arrow notation. Show the formation of reactive intermediates when the following undergo heterolytic cleavage. So here in this case heterolytic cleavage is taking place, and which means one of the groups of atoms or an atom or a group of atoms will get a negative charge where the other will be positively charged. So in case of CH3 and SCH3, so here there's a bond between carbon and sulfur. So that's basically going to be like this, right? So compared to carbon and sulfur, sulfur is more electronegative than carbon. This means that the lone pair of the electrons of the bond will go towards the sulfur, leaving carbon CH3 with a positive charge plus SCH3 with a negative charge. The next one is CH3CN. So here you have both carbon atoms, but nitrogen is more electronegative than hydrogen. So the electrons of the bond will go towards the CN, leading to the formation of CH3 plus CN minus. Not only that, CN is electron withdrawing in nature. CH3 and Cu. Between carbon and copper, copper is less electronegative than carbon, which means the electrons of the bond will go towards the carbon, leading to the formation of a carbanion plus Cu plus CH3 minus plus Cu plus. The next one is giving justification. Categorize the following molecules or ions as nucleophiles or electrophiles. So nucleophiles are nucleus loving, or they are electron rich, whereas electron rich, right? Whereas electrophiles are electron loving, which means they're electron deficient. So let's start. HS minus. HS minus is a nucleophile. So you have HS minus, which is the nucleophile because it has minus charge. BF3 we know is a neutral electrophile because the boron's octet is not completely full, and so it would it's electron deficient. Next, C2H5O minus, it has a negative charge, so it is the nucleophile. Then we have CH3 taken thrice N, which is a nucleophile again because of the lone pair of electrons on the nitrogen. Then Cl plus is the electrophile because it is positively charged. CH3CO is again going to be an electrophile because of a positive charge again. CO. Next you have NH2, which is a nucleophile because of the lone pair of electrons. And then you have NO2 plus, which is an electrophile because it's electron deficient. Next, we need to identify the electrophilic center of the following. So electrophilic center is basically the electron deficient center of the compounds. Here, oxygen and carbon. Between oxygen and carbon, the carbon atom is less electronegative than oxygen, which means it is electron deficient. So this will be our electrophilic center. In between carbon and nitrogen, carbon is less electronegative, so nitrogen will pull the electrons towards itself, so carbon becomes electron deficient. Similarly, CH3, the carbon becomes electron deficient due to the presence of a more electronegative atom, that is iodine. With that, we complete the Intext questions related to the electrophile, nucleophile and the curved arrow notation.